So let's talk about finding parametric equations and arc length. So we know from earlier in the year to find arc length of a curve f of x, so a rectangular curve that's defined in terms of one variable between an x coordinate of a and b or y coordinates, right? Doesn't matter, whatever you're defined with. We can use the integral of from a to b from square root of 1 plus the derivative squared dx. So we're going to manipulate this formula to figure out how to do that in terms of parametric equations. So we can say, well, f prime is really just dy dx. So let's rewrite this as the integral from a to b, 1 plus dy over dx all squared times the square root times dx. Right, so we want dt's to start showing up, right? Because our parametric equations are in terms of t, right? Our parameters. So we need to have a dt in there. Okay. So what I'm going to do is I'm going to rewrite this as, we're going to make that one fraction on the inside. Right, so this is the same thing as dx squared, right, plus dy squared all over dx squared, right, times dx. Okay, so if we keep manipulating that, right, we can bring this out, right, we can take the square root of that. So we have from a to b, now we have 1 over dx times the square root of dx squared plus dy squared, right, dx. Now, these things cancel out, which isn't super great mathematics. So this isn't like super formal or like everything totally should be kosher or whatever, right? So we can get rid of the dx's, and then to get the dt's in there, what if I multiply by dt over dt? We'll just keep this all on the same screen here. Right? So I'm going to leave this alone for right now. dt, right? And that bottom dt I can write as the square root of dt all squared. So now because it's inside of a square root, I can distribute it through. This actually is going to become dx over dt squared plus dy over dt squared dt, right? So we can kind of see how we can manipulate that original arc length integral formula to make it easy for parametric equations. So instead of having 1 plus dy dx squared inside the square root, we have the derivative of x in terms of t squared plus the derivative of y in terms of t squared, all under the square root, and we're going to take the integral of that, right? And instead, a and b are usually going to be in terms of our parameter values. Okay, so let's do one to see how this works. We're going to do this without a calculator. So we're going to find the length of the curve defined by the parametric equations x equaling t squared and y equaling 4t cubed minus 1 from 0 to 1 on the t-axis, on our parameter, right? So we got to find dx dt and dy dt. So dx dt, right, is equal to the derivative of t squared, so that's going to be 2t, and dy dt is equal to 12t squared. Okay, so then if we go ahead and set up our arc length formula, right, arc length is going to be the integral from 0 to 1, because that's what it said our interval for t is, we got 2t squared plus 12t squared all squared inside of our square root dt. Okay, so let's do a little bit of algebra manipulation. So we got the integral from 0 to 1, and this is going to be 4t squared plus 144t to the 4th dt. Okay, so if I do a little bit of manipulation, right, we got, whoops, didn't mean for my notification sounds to go off. If I factor out 4t squared in here, I can get 1 plus, and then it's too early to do mental math in my head. All right, so that's going to be 36t squared. Running out of space here, that's okay. So then if I take the square root of 4t squared, I'm just going to come here so I have time. Space. Whoa, okay. We got 2t from the derivative of 4t squared times the square root of 1 plus 36t squared dt. Okay, so now I'm just going to move that over. Okay, so now I can use u substitution. So u is going to equal to 1 plus 36t squared. And I'm picking that because it's under the square root, so it's the more complicated part of the problem. So definitely want to get rid of that if I can. And then if I take my derivative, du is going to be 72t dt. So I want to get 2t dt if I can. So if I divide that by 36, right, 1/36 du is going to equal 2t dt. So now I'm covering that stuff with my 1/36 du. So I can make this the integral of, okay, if I plug in t of 0, let's just start that over. T of 0, that's going to become u of 1. And if t equals 1, 1 plus 36 is going to give me 37. All right, so now I no longer have to switch back. And then that's going to give me the square root of u, and then that 1/2 dt, that 2t dt is going to turn into 1/36 du. Okay, so if we integrate that, I'm going to get 1/36, and then power rule, that's u to the 3/2 times the reciprocal, evaluated from 1 to 37. Okay, so that's going to reduce, let's see, 2 and 36 becomes 18 and 1. 18 times 3 is 1/54 times u to the 3/2. So that's going to become 37 to the 3/2 minus 1. And then I'm actually just going to leave it as that because 37 to the 3/2 is not going to be something super easy to manipulate. So we're just going to leave that as our